the derivative of any monomial. Now, we know what polynomials look like. A monomial is a polynomial with one term. It might have a coefficient, a variable raised to some power. That's what a monomial is. Don't be scared of it. d dx, we're taking the derivative of any monomial. Look what I'm doing to get this. N is your exponent or your power. I do exponent times coefficient, so a times n. I keep the variable the same, and then I subtract 1 from the exponent. So when I see the power rule problem, I think to myself, multiply and subtract. Now, what am I multiplying? I'm multiplying exponent by coefficient. And when I say subtract, I say subtract 1 from the exponent. Now, do I really want to explain all that? No, I'd rather just use symbols. I'm doing this. I'm taking my exponent and I'm multiplying by whatever coefficient I have there, and then that becomes my new coefficient, and then I simply subtract 1 from my exponent. And that's the power rule. Here are some examples with the power rule. When y equals 20, I like to do this. F dash of x, or f prime of x, is 0. How do I know that? Well, this is a constant. We already learned that the derivative of any constant is 0, because this is a line at 20 and its slope is 0. Now, if I wanted to use the power rule, look what I would do. I would say this is x to the 0. We know by definition x to the 0 equals 1. So I can add that in there. Then 0 times 20 is 0. 0 times anything is 0. So we can see that this is correct. Here, f dash of x is equal to, I'm going to treat each of these as a monomial. Of course, this is a binomial if we're talking about what kind of polynomial is it. But I take each one as a separate monomial. Well, the derivative of a constant is 0, plus the derivative of a linear term will simply be the coefficient. Now, why is that? Look, I'm going to do 7 times 1 is 7, x to the 1 minus 1. This becomes x to the 0, and x to the 0 is 1. 1 times 7 is 7. So would I really write 0 plus 7? No, I would just write the derivative here is 7. F dash of x for this trinomial, I'm going to take it one monomial at a time. 2 times 5 is 10. X to the 2 minus 1 is x to the first. Plus, this is 3. This is x to the first. Oh, well, we already learned quite well, I think, that the derivative of any linear term is simply the coefficient for reasons I showed up here. Am I really going to do 1 times 3 is 3, x to the 1 minus 1 is 0? No, I just can quickly tell you that the derivative of a linear term is the coefficient. And of course, I'm not going to write plus 0 here because the derivative of any constant is 0. I'm going to quickly do this, and you can see I'm starting to do them in my head. F dash of x here is, well, a derivative of a constant is 0. I'm just going to ignore that. Then I'm going to multiply 2 times negative 3 is negative 6. X to the 2 minus 1 is 1. Then I'm going to go 4 times 3 is 12. X to the 3 minus 1 is 2. Do I really keep the 1s there? No. The derivative is negative 6x plus 12x squared. Here, our derivative in the bottom here is, I'm going to go 6 times 13, which of course is 78. X to the 6 minus 1 is 5. Minus, careful, your pluses and minuses, 2 times 9 is 18. X to the 2 minus 1, which is x. And then, of course, the derivative of any linear term is simply the coefficient. Again, that's 7 times 1, x to the 1 minus 1, which would be 7, x to the 0. But I'm not going to bother writing that. I know that that's going to be x to the 0 is 1, so 7 times 1 is 7. Beautiful derivatives, beautiful examples of the power rule.